All right, in 6.5 here, we're going to get back to some things that maybe look more like just solving regular equations. Now that we've been through that hurdle of trying to rearrange the equations and figure out what's going on. So let's get a nice yellow color that'll show up. So key number one is you want to make sure that you're getting the thing with the radical all by itself. So we're going to start by subtracting 3 to both sides. So I have the square root of 2x minus 3, all covered by the square root. It equals 5. The next thing we're going to do is we're going to rearrange, well, I'm not going to rearrange, to get rid of our square root. You guys have been through this so many times. It might seem like, what are we doing? This seems like something we've already done, and it is. So the square and the square root cancel each other out. 2x minus 3, 5 times 5 is 25, right? That's how we square. You're going to add your 3 over now. So 2x equals 28 and divide it by 2. Bingo. You got 14 as your answer. And that's how we deal with regular square roots. Hopefully at this point, that is something you've already done. All right, our next problem is presented a little bit different. Okay, remember this is the same thing as having x plus 1 squared in here and having a cube root in there. I do not want to change that format back, right? Once we have this fractional exponent, we want to keep it, but I want to get that thing alone. So here it goes, divide by 3 to get rid of this 3 hanging out there. X plus 1 is to the 2/3 power, and it equals 4 now. All right, so the thing we haven't really discussed is the square root up here. When we had, let's just say it's the square root of x, that would be the same thing as saying the 1/2. So what I did to solve it is we squared it, which is 2 over 1. So what we're going to do is we're going to use reciprocal powers. Reciprocal powers, so if it says 2/3, I want to use 3 over 2. Okay, reciprocal, that's our academic term. For you, you're saying, I just want to flip it over. And that's what we're going to take it to that power. Okay, so be very careful on your calculator here. So this becomes 6 over 6. So this is just x plus 1. All right, so let me jot a little note here. So this is 4 caret parentheses 3 divided by 2 on your calculator. Okay, in other words, we want to take the square root of 4 and then cube it. So this is going to turn into 8. If this doesn't say 8, we typed it in wrong. Okay, so that has to happen. So remember, it's the power over the root. So what we'd like to do is take the square root of 4, which is 2. 2 to the 3rd power is 8. Subtract the 1, x equals 7. And that means if I plug 7 back in way up here, we'll be in good shape. Right, so that's the new way of looking at the same thing. All right, so quick question. See if we have that. So if I made this x plus 1 to the 3/5 power, what power would you take that to? All right, if you said it has to go to the 5/3, then we're in good shape. Okay, remember, I just want to use this reciprocal power, so it becomes 15 over 15, which is 1. Okay, so that's your side question here. All right, if it doesn't look the way we want it to be, then change it. Okay, so we're going to do 2 things at once here. All right, I'm going to get rid of this 1 because it's not covered by the square root. While I'm doing that, I'm going to make it x plus 1. It equals 24. We're all good with that. This is to the 3rd power and the 5th root. Oh my goodness, we just had that, right? Total coinkydink. That means I want to take it to the 5/3. All right, here's where things get a little bit different than in the regular stuff. Now, is 24 a perfect cube? No, so I can't really do the cube root. So here's where we start working with some decimals. All right, the other thing I want you to understand is this numerator, the power, is bigger. That means my answer has to be larger than the base I started with. So when I jot this in here, remember it's 24 caret parentheses 5 divided by 3. This says 199.688. So we're going to go 199.7 and then subtract 1. So x in this equation is 198.7. And we just annihilated that problem. Okay, so we want to see things as this fractional exponent. That makes it so much easier to figure out what to multiply it by or what power to take it to. Shouldn't say multiply by. What power to take it to. All right. So that's round one. Okay. That's the type of stuff like I could ask my really good Algebra 1 students to do. Now we're going to get to Algebra 2 because you're my Algebra 2 students, right? So let's add the 5 because I do want to get this square root of x plus 7 all by itself. Right? Remember, this is the same thing as the 1/2 power. So if this were the 1/2 power, so I'm going to use that notation. What power do we take it to? Right? We're going to square it. So left-hand side, this is 1, so it's x plus 7. Right-hand side, look why this is an Algebra 2 problem, my friends. Now I have to FOIL this. So I got first is x squared plus 5x on the outside plus 5x on the inside plus 25. Will this problem ever end? Not right now. I got 10x in the middle. Now, here's the next thing. This is going to be a lot of work, okay? So take your time, make sure you understand what's happening in all these steps. We FOILed it, we combine like terms. Anytime I have a quadratic and a linear term, I would like all of this on one side. So I'm going to subtract an x and subtract the 7 because I really want this to factor out. I really want this to factor out for you. But I can't guarantee it just yet. So 25 minus 7, that's 18. So here's the question. Are there factors of 18 that add up to 9? Remember 18, 1 and 18, 2 and 9, 3 and 6. Bingo, there they are. X plus 3, x plus 6. That means x plus 3 equals 0 and x plus 6 equals 0. X equals negative 3, x equals negative 6. But there was something I kind of skipped over. It says check it for extraneous solutions. All right, remember in like 8th grade when you started solving equations, the teacher said, oh, plug it back in. It's so cute. It works. Now you really have to. Some of these things might not work. Okay, and I can give you a heads up right now. When it says equals x, all right, we got to be careful. Whatever happens here, this negative 6 really concerns me because I'm going to take something and subtract 5 from it. That can't be negative because of all this stuff going on. So we're going to check it out. I'm going to start with my negative 3 because I believe that's in good shape. Okay, so negative 3 plus 7 minus 5. It has to be negative 3. So now we're checking it. So this is 4 minus 5 equals negative 3. Okay, that was the square root of 4. Square root of 4 is 2 minus 5 equals negative 3. This is good. This is good. All right, here's the one that I was concerned with, right? Negative 6 plus 7. We're going to take the square root of that. We're going to subtract 5. It has to turn out to be negative 6. So I'm going to take the square root of, this turns into 1, right? Square root of 1 minus 5. What's 1 minus 5? Is it negative 6? No. This is known as an extraneous solution. When it says to check your results, we really have to now. Okay, so this is part of becoming that Algebra 2 student and really getting into some serious solving situations. All right, we're going to leave problem number 5 for another day. Okay, we're going to try and find one down here and get you started with a couple of these problems. All right, so we're going to pull this way to the side. We're going to take a look at number 14 here. We have the square root of x plus 2 minus 2 equals 0. First things first, get the square root part alone. We're going to add 2. Square root of x plus 2 equals 2. What do I do next? Remember, these are just like Algebra 1. We're going to square. The square root and the square cancel. X plus 2 equals 4. Subtract the 2. X equals 2. This is our regular solving. Not a big deal. Okay. All right. Problem a lot of kids get concerned with every year. Something like 23. So what's our first step? Subtract 3. Very good. 4 minus x, that is to the 3/2 power, equals 11 minus 3 is 8. Okay. So the real question now is, what power do I take this to? 2/3. 2/3. Okay, so it's 4 minus x equals, And if I take 8, 8 is a perfect cube. Okay, so I'm going to do the cube root down to 2 and then square it up to 4. So it's going to be 4. All right, so here's what I need you to make sure you're doing on a calculator. 8 caret parentheses 2 divided by 3. Okay, this caret sign is right above your division. All right, next thing we'll do is subtract 4. Negative x equals 0. Oh boy. And divide by negative 1. X equals 0. Not too shabby. Not too shabby. Okay, that's what it's about. Okay, the last thing we can ask you to do, and we'll take 27 here and work up the page just a little bit. The square root item is already by itself, so I'm going to start off by squaring both sides. So I have 5 minus x equals x plus 1 times x plus 1. Let's FOIL that. 5 minus x, I got x squared, minus 1x, it's minus, plus 1 and plus 1, so it's plus 2x. Don't forget your plus 1. We want this to factor. I'm going to add x and subtract 5. I'm going to add x and subtract 5. Again, working up the page here. X squared plus 3x minus 4. Are there factors of 4? Let's subtract to give you 3. Yes. 4 and 1. I want positive 3, so positive 4 minus 1. Possible solutions. Negative 4 and positive 1. Notice this one says we got to check it. Check, check, check. So remember, we're going back to the originals. Negative 4. 5 minus negative 4. We're going to take the square root of that. Is it equal to negative 4 plus 1? Is it equal to negative 3? Let's find out. So this is going to be 9 to the 1/2 power. Is 3 equal to negative 3? No. 4. You're no good for us. You are no good for us. What about 1? Positive 1 goes in. 5 minus 1. We're going to take the square root of that. And then we need 1 plus 1. So is it 2? 5 minus 1 is 4. To the 1/2 power is 2. 2 equals 2. 1 is our only real solution to this problem.